Okay, we're talking about hazardous materials. This is chapter 10 in the IFSTA manual. This is objective 5, which is we're going to explain the classification of health hazard materials. You can remember back in objective number 4, we were talking about physical hazards. Now we're going to look at the health hazard aspect of hazardous materials. So these are materials where a single brief exposure to the hazardous material can result in death, injury, or incapacitation. So we're looking at toxicity limits in the model codes. So the International Fire Code, the IFC, they do have areas in the back of the book from chapters 50 on, of which they'll talk about toxic materials. Uh, and those their limits are lower than those that you would see with the Department of Transportation or the transportation that Transportation Canada, how they regulate. For example, under the model fire code, sulfur dioxide is neither a toxic or highly toxic gas. However, under DOT and TC rules, it is a toxic inhalation hazard. This illustrates why a DOT label or a placard cannot always be used as a basis for classifying hazardous materials in fire codes. So we have to do a little bit of homework when we look at placarding and really trying to understand, is it really an issue from our amended codes, or I should say our adopted fire code, or is it or the thresholds of toxicity haven't been made. So there's highly toxic and toxic materials, which include substances capable of producing serious illness or death once they enter the bloodstream. For example, anesthetics and narcotics, ethers, reduce the muscular powers of vital bodily functions, can result in a loss of consciousness, suppressing breathing, and ultimately death. So it's something that once we start understanding and classifying what the materials are and how they're used, then we have to see if it meets the limits of our amended codes. So when we talk about irritants, they produce some type of local inflammation or irritate the skin, respiratory membranes, or eyes. They may uh, enter through the body. They could be inhaled, ingested, absorbed, or somehow injected into the body. It's imperative that as inspectors, we become aware of how materials work and how toxic they can be, so that we can understand what PPE is required, whether it's for occupants or for yourself. Um, just to be clear, that PPE is important part of your job as well as the actual inspection itself. So uh, the warning, if you will, that when we do inspections um, where there are toxic materials, regardless of why they're there, that we do have our PPE and making sure that we have the appropriate PPE, that it's taken care of in the appropriate manners, so that we can minimize any type of uh, we want to make sure that we minimize any type of exposure so that we can stay safe and healthy. So as inspectors, we have to consider what the threshold limit value of potentially toxic materials are, so we know and be able to evaluate and have our exposure kept to a minimum. The value of this type of concentration uh, given that the body generally can tolerate without any ill effects. Um, the American Conference of Governmental Industrial Hygienists, the ACGIH, and the National Institute of Occupational Safety and Health, NIOSH, they they uh, they published threshold limit values of materials. So these materials are useful when an inspector needs to rate the maximum allowable concentration of a toxic material when evaluating proper ventilation. So uh, the classification of health hazard materials as either toxic or highly toxic is based on materials acute toxicity, that's the LC50 or the LD50 value. The values in this method of measurement represents the lowest exposure that will produce an adverse consequence to the body. So LD50 refers to the ingestion dose of a given substance that was lethal to 50% or more of the test population when they swallow or ate the substance. The LC50 refers to the concentration in the air of a given substance that killed 50% or more of the test population when they inhaled or absorbed the vapors, fumes, or mists of the substance. So there are two sources for hazardous material toxicity data, and that's the Registry of Toxic Effects of Chemical Substances, it's the RTECS, and SACS's Dangerous Properties of Industrial Materials. So uh, examples of a highly toxic material include fluorine, hydrogen cyanide, methyl ethyl isocyanic acid, and white phosphorus. Examples of toxic material include chlorine, aniline or aniline, sulfuric acid, and chromium trioxide. So keep in mind we have two classifications, toxic and highly toxic. And when you have a chance to look at your International Fire Code in the back section, chapter 50 and on, we'll talk about highly toxic and toxic materials and what the limitations are. So we're going to talk about corrosives, but we have one question, and it's how are highly toxic and toxic materials classified? In your manual, you go to page 397, take a look, get familiar with the two terms and the classification of each term. Again, it's on page 397. Next, we're going to talk about corrosives. Uh, they exist in all three physical states, and they are extensively used in water and wastewater treatment, metal finishing, extraction, and processing of minerals. They are also building block chemicals used in the manufacture of a variety of products such as uh, food, pharmaceuticals, plastics, and other chemicals like sulfur dioxide or ammonium nitrate. Classification of corrosives in the model fire codes is assigned when the material causes irreversible alteration or visible destruction to human skin. At higher concentrations, corrosives are a health hazard because of the contact on skin or eyes that can cause burns. Classification criteria used in fire codes is the same as the UNDMGC criteria, and materials classified as corrosives by DOT or Trans Canada has the same classification in the fire codes. Okay, let's spend a few minutes regarding mixtures. So we look at a mixture as a substance that contains two or more materials that are not chemically combined. Mixing chemicals, they can change once they're mixed. They can change their properties. Their chemical and physical makeup can change, and that could be something like, what their boiling point is, what their melting point might be, or any other type of characteristics that defines the substances when they're not combined. Um, can also change the hazard classification of a material. The big example that is, or a classic example is aerosols. Aerosols are packaged by mixing a propellant with a base product, which may or may not be flammable. When you mix the two chemicals, they create a new compound with its own unique hazard. So we take, for example, when metal is plated with chrome, the process starts by mixing solid oxidizer chromium trioxide with water. So the mixture creates a solution of chromic acid, which is not an oxidizer, but a corrosive. So as an inspector, we're evaluating uh, these processes, and we need to understand, even though we've got the end result, uh, we're looking at the end result, what went into that to get to that end result. And so we're looking at the hazards before they were put together and what are the hazards when they are put together. So the big question is how does mixing two or more materials impact the hazard classification? If you go to page 399 of your manual, take a look, get familiar with that, and understand it. Uh, but that's 399 of your manual. So incompatible materials. Our model fire codes define incompatible materials as two materials that are mixed and cause a reaction that generates the following type of characteristics. It could be heat. They could generate fumes or gases or other byproducts that are hazardous to life or property. Um, on the slide, I put in there table 10.6, which gives you more detail or illustration about incompatible materials. Uh, Mixing hazardous materials that are not chemically compatible may you may be looking at an irritant, uh, off gassing or giving off fumes that are noxious or toxic. Might be a little bit more volatile, or you might have generates uncontrolled pressure in containers or tanks that may result in an explosion or possibly a fire. The model codes address incompatible hazardous materials in storage, and if you look in chapter 50 on in the International Fire Code, it talks about segregating, separating, and when they can be combined or what can be combined versus not being combined. So identifying incompatible storage requires when you have to understand the hazard and how it's classified, and when you and it would be for both materials from beginning to the end. You're looking at understanding, reviewing the SDS sheets, the safety data sheets, which should be available, and comparing the reactivity information to determine their ability to be compatible. So uh, examples of hazard classes always assumed to be incompatible when you look at flammable and combustible liquids and an oxidizer. Oxidizers and organic peroxides, acids with bases. When storage arrangements are questionable, the matrix can help inspectors determine if they should require additional information to confirm compatibility of that stored material. Again, we look at table 10.6. That's on page 400, and get yourself familiar with with that table and understand uh, the ramifications of when we uh, do incompatible materials. So now we start getting into some of the code requirements. So when we look at hazardous materials and their incompatibility, uh, they are considered separate if there's a distance of 20 feet or more between them, um, or if the materials is stored in an approved container, cabinet, an exhaust enclosure, or anything that is designed to separate materials from other materials or other materials in the workplace. Um, the materials are separated by a non-combustible line of sight barrier, so getting some actual physical segregation. Um, all the codes exempt hazardous material packages weighing less than 5 pounds or with a volume of zero point 0.5 gallons or less. So the review question is, what is required to identify the appropriate storage classification of incompatible materials? I ask that you go back to your manual, review pages 400 to 401, and get yourself familiar with how incompatible materials, uh, what are they, how they can be stored safely, and and those types of important inspectional considerations.